Hi friends, welcome back to the course of data structures. Today I'm going to explain, since in previous lecture I started the concept of recursion. Today I'm explaining the Fibonacci series, identifying the nth Fibonacci value using recursion. So whenever I talk about Fibonacci series, so you could remember that series 1, 1, 2, 3, 5. That means the sum of two previous numbers will be the current number, starting with 1, 1. That means the initial value is 1 and second value is 1. So consider like this, 1 1, so 1 plus 1 is 2, then 1 plus 2 is 3, then 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, 8 plus 13 21, 13 plus 21 34, then 55, then it is how much it is, 89. Likewise it will get increase. So the same thing can be generated like using Pascal triangle also. So Pascal triangle, hope you remember that. 1, so starting with 1 and ending with 1. Then this 1 will be represented here, and 1 plus 1 is 2. So then this one will be here. Then this one will be here. 1 plus 2 is 3. 2 plus 1 is 3. Then this one will be here. Then 1. 1 plus 3 4. 3 plus 3 6. 3 plus 1 4. And this one. And 1. 5, 1 plus 4, 10, 6 plus 4 is 10, 4 plus 1 is 5 and 1. So now, and another row also I'll display, 1, 6, 15 and 20, 15, 6, 1. Now you can see the first value of Fibonacci is 1, the second value is also 1, the third value is 1 plus 1, that is 2. The fourth value is 1 plus 2, that is 3. The fifth value is 1 plus 3 plus 1, that is 5. The next value is 1 plus 4 plus 3, 6, 5, 3, 8. The next value is 1 plus 5 plus 6 plus 1, that is 6, 6, 12, 13. Likewise, you can imagine what could be the next value. So if you want to see, you can see 1, 7, 21, 35, 35, 21, 7, 1. So which is equivalent to 1 plus 6 plus 10 plus 4, 6, 10, 16, 20, 21. So you can observe the same thing. So 1, 1, 2, 1 plus 2, 3, 2 plus 3, 5, 3 plus 5, 8, 5 plus 8, 13, 13 plus 8, 21. This is the generation of Fibonacci series. Then this is Fibonacci of 0, and if I consider it as an array, this is Fibonacci of 0, Fibonacci of 1, 2, 3, 4, 5, 6 and 7. Now what is the Fibonacci of 7? Based on this, what we can say, Fibonacci of 7 is equivalent to Fibonacci of, that is it is 13 plus 8. What is 13? Fibonacci of 6. What is 8? Fibonacci of 5. Then again it is 8 plus 5. This 8 is fib of 5. This is fib of 4. So likewise it is a recursive, it will generate the recursive tree. So I'll draw the complete recursive tree, you can see once. So I'm generating the Fibonacci for 7. Let us assume that Fibonacci of 7. So which is equivalent to fib of 6 plus fib of 5, which is equivalent to fib of 5 fib of fib of 4. This one, so fib of 4, fib of 3. This one, fib of 3, fib of 2. This one, fib of 2, fib of 1. Fibonacci of 1 is 1. This one, fib of 1, fib of 0. This is 1 and this is 0. Sorry, this is also 1. So now fib of 2 is equivalent to fib of 1 and fib of 0. This is 1, this is also 1. Fib of 3 is equivalent to fib of 2 and fib of 1. So fib of 2 is equivalent to again fib of 1 and fib of 0. So this is 1, this is 1, this is 1. Now this one will be expanded, fib of 4. The same thing will be expanded, fib of 3. So I am giving the same notation to here. And fib of 5 will be expanded like fib of 3 and fib of 2, this one. Sorry, I should not forget this. This one will be fib of 1 and fib of 0. Fine. This one is 1 and this one is 1. So fib of 5 is fib of 4 plus fib of 3. So fib of 3 is fib of 2 plus fib of 1. This is fib of 1 plus fib of 0. This is 1, this is 1 and this is 1. Now you can see 1 plus 1 is 2 here. Fib of 2 is 2, fine. All the time it is 2. Then 2 plus 1 is 3, fine. Then is 1 plus 1 is 2. 3 plus 2 is 5, good. And 1 plus 1 is 2. 2 plus 1 is 3. 5 plus 3 is 8 here. Okay. Similarly, this one 1 plus 1 is 2. 2 plus 3 is 5. 8 plus 5 is 13. Fine. So then 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 5 is 8. 13 plus 8 is equivalent to 21. So fib of 7 is equivalent to 21. So now in this process we had seen that this is recursive tree. So if you are able to generate the recursive tree for the for any program, then it is very easy to write the program. So what we are doing here, so simply we are doing whenever Fibonacci of 0 is there, then we are returning 1, or Fibonacci of 1 is there, then we are returning 1. Otherwise we are finding the, if fib of 2 is given, we are finding fib of 1 plus fib of 0, that means n minus 1 plus n minus 2. So what I can write is fib of n is equivalent to fib of n minus 1 plus fib of n minus 2 if n is greater than 1. So it will be 1 if n equal to 0 or n equal to 1, or we can say it is else otherwise. And this is another important thing, we have to know how to write the mathematical function. So now this mathematical function I am converting it into program. See now how I am converting it to program. Int fib, I am passing only one value n, because it is the n which is returning integer, because it is returning either sum of these two things or 1. Fine. Now what we are going to check, if n equal to 0 or n equal to 1, then we have to return 1. So else, that means if n is greater than 1, then what we have to return? So we have to return Fibonacci of n minus 1 plus Fibonacci of n minus 2. Like in factorial program, I explained the process of recursive tree using stack. The same thing will happen here. First, if I give fib of 5, then it will be creating fib of 5 minus 1, 4 plus fib of 3. That means it is going to identify fib of 5, 4, 3. Then 4 will be 3, 2. Then 3 will be 2, 1. Then 2 will be 1, 0. So 1 will be 1, 0 will be 1. Fib of 1 will be 1. So likewise the sum addition will be in backtracking. That means the reverse addition will be performed. So you can see like that. From bottom, 1 plus 1 is 2. So 2 plus 1 is 3. So similarly 1 plus 1 is 2. 3 plus 2 is 5. Then 1 plus 1 is 2. 2 plus 1 is 3. 5 plus 3 is 8. Then 1 plus 1 is 2. 3 plus 2 is 5. 8 plus 5 is 13. So you can see like that, 1 plus 1 2. 2 plus 1 3. 5 plus 3 8. 13 plus 8 is 21. Likewise, it is going to perform the operations. Now first I will write the same program in C language, and I will execute it and I will show. So fib1 dot c, let us assume that Fibonacci 1. So hash include stdio.h int fib of int n. So if n equal to 0, so or n equal to 1, n return 1, else return fib of n minus 1 plus fib of n minus 2. So simple program. So int main, so I'm calling printf %d. Then what we can do, Fibonacci of n is, or %d is %d. So that is n comma fib of n. I'm calling Fibonacci function. So int n printf \n enter n scanf %d ampersand n. So this will be the program, simple program. So control F9. So there are no errors. Control F10. So enter n value 7. It is 21. Control F10. 10. 89. Control F10. Suppose if I want to find the Fibonacci of 20, then it is 10946. So we'll take some time to perform these operations, but system can give the same output in the less time if it is adjusted to that. Now see. What is the time complexity of Fibonacci series? What is the time complexity of Fibonacci series? So you can see here how many additions it has performed at the first level. 2 additions. Fine, 2 additions. Then at second level, so 1, 2, 3, because this one also 1, 2, 3, 4, 4 additions. Then next level 1, 2, 3, 4, 5, 6. So whenever I had given this one, yeah, fine. This one is also Fibonacci of 3, so it will be expanded anyways. You might have understood that. it will be almost 8 additions. Or yeah, it is 8, because this one will be 1 and this one will be 1 2, and this one 1 2 1 2 3 4 5 6 7 8 9 10 11 12 9 10 11 12 13 14 15, or at this level it will be 16 totally, sorry, 16. And next level this one will be vanished, so 2 will be reduced. So if you reduce 2 and if you can 16 32, so it will be 30. So likewise the number of additions, that means at first level it will be 2, second level 2 square, third level 2 cube, fourth level 2 power 4. That means it is performing like operations as the time complexity will be 2 plus 2 square plus 2 cube plus 2 power 4 plus, and till the depth of the tree, or till the height of the tree. So since it is difficult to identify time complexity based on this, so what we can do is T of n is equivalent to T of n minus 1 plus T of n minus 2, and don't forget that we have 1 plus 1 also, because for condition checking. So this is the time complexity, as well as we are checking either this or this condition. One condition checking will be there, so plus 1. So this is equivalent to T of n minus 1 is nothing but T of n minus 2 plus T of n minus 3 plus 1 plus T of n minus 3 plus T of n minus 4 plus 1, and this is whole plus 1. So this one itself is this one, and this one itself is this part, and this plus 1 is this part. Now T of n minus 2 is equivalent to T of n minus 3 plus, so sorry, from this what we can write, which is equivalent to T of n minus 2 plus 2T of n minus 3 plus T of n minus 4 plus 3. Fine. Then which is equivalent to T of n minus 3 plus T of n minus 4 plus 2 into T of n minus 4 plus T of n minus 5 plus 1, here also plus 1, plus T of n minus 5 plus T of n minus 6 plus 1 and plus 3, which is equivalent to T of n minus 3 plus 3T of n minus 4 plus 3T of n minus 5. Okay, so plus T of n minus 6 plus 1 3, and because 1 plus 2 is 3 plus 4 plus 3 is 7. Then next level, so which is equivalent to T of n minus 4 plus T of n minus 5 plus 3 into T of, sorry, plus 1 plus 3T of n minus 5 plus T of n minus 6 plus 1 plus 3 into t of n minus 6 plus n minus t of n minus 7 plus 1 plus t of n minus 7 plus t of n minus 8 plus 1 plus 8, sorry, plus 1 plus 7. So which is equivalent to t of n minus 4 plus 4t of n minus 5 plus 4t of n minus 6 plus what could be the next value? Yes, 4t of n minus 7, sorry, this will be 6t of n minus 6 plus 4t of n minus 7 plus t of n minus 8 plus 1 4 7, because 3 here, 1 4 7 7 8 plus 7 is 15. Now based on this one we can imagine the next level also. T of n minus 3, sorry, n minus 5 plus what could be the next value? 10t of 10 or 5t of n minus 6 plus 10t of n minus 7 plus 10t of n minus 8 plus 5t of n minus 9 plus t of n minus 9, so t of n minus 10 plus it will be 31. See, we can observe this one value, this one initially 1, okay, and now it is 2 square, that is 2 power 1 minus 1, there is 2 square minus 1, then this is 2 cube minus 1, then this is 2 power 4 minus 1, then this is 2 power 5 minus 1, and at some instance it will be 2 power k minus 1. Whenever all are t of 1s, it will be 2 power k minus 1 operations that we are going to do. 2 power k minus 1 is nothing but almost it is equivalent to 2 power n. If k equal to n, it is 2 power n minus 1. So which is equivalent to 2 power n. The time complexity of Fibonacci series is equal to 2 power n minus 1. Sorry, 2 power n. So if n value is given, then it needs 2 power n operations to perform the time complexity. See, we can see from here we can observe the same Pascal triangle. Initially it is 1 1 and this is 1 2 1, this is 1 3 3 1, and this is 1 4 6 4 1, and this is 1 5 10 10 5 1. So it is a kind of Pascal triangle. The number of operations will be equivalent to the leaf node of the Pascal triangle. So which is almost equivalent to 2 power n operations it will perform. So maybe less because since it is not complete tree, so it will perform the 2 power n operations. So this is the way of computing the time complexity for Fibonacci series. So hope you understand the Fibonacci series computation using recursive function clearly. So and the time complexity of finding the Fibonacci series, which is equivalent to 2 power n. So that means which is equivalent to order of 2 power n, upper bound. So we cannot compute exact theta bound, so it is order of 2 power n. So the time complexity for Fibonacci series is using recursion is order of 2 power n. So thank you for watching. So hope you understand the Fibonacci series using recursion. In next video, I'll explain a tricky question. So for the recursive function, one or two tricky questions so that you will understand. So what could be the time complexity analysis for those functions as well. So thank you for listening, and subscribe to my channel if you are not subscribed, and keep on watching the complete course. Thank you so much.